Section 3.3 is called graphing linear equations, which is the overall idea of this whole unit. In this, we're going to be able to identify linear equations, say what makes something linear versus cubic or quadratic. We're going to be able to complete ordered pair solutions of linear equations, which we've done a little bit in the past. We're going to graph linear equations by plotting points, graph linear equations by the intercept method, and finally identify and graph horizontal and vertical lines. So starting out just with what a linear equation looks like. The key thing in a linear equation is that the power on y is an understood 1, the power on x is an understood 1. So if you get like a power of 2 on the x, or if you get it under an absolute value bar, if you get the power of 3 on the x, any of those will not give you lines, they'll give you different shapes. Specifically, this is what a line looks like when we just have the single power of y, single power of x. Here you get a curve when you have the second power of x. Here you get kind of a V when you have the absolute value of x. And here you get a cubic curve when you have the third power of x. So these three are all examples of things that are not lines. When we talk about linear equations, we're talking about lines that are straight like this. Single power of y, single power of x, no absolute value bars. So those are the types of equations we're really dealing with here. Any equation that's linear can be written in general form, which is ax plus by equals c, where c could be 0 if it wanted to be. A and b can't both be 0 at the same time, but one could be 0, and I could still have a linear equation. This is called the general form of a line. Note that a linear equation x and y, the exponents on x and y are 1. So which of these following equations are linear equations? If I look at the first one, here I don't see any powers, I'm good, this is a linear equation. If I look at the second one, b, I see this third power, no good, that's going to cause it to be a cubic. For c, this 1/2 is a fraction, that's fine, I'm allowed to have something being multiplied by a half, I just can't have a different exponent here or here, which I don't, so c is also a linear equation. I need to be able to solve equations for y in order to put things into slope-intercept form, which is what we're building towards at the end of this unit. So we need to get used to starting with something like this and saying, how do we get 1y by itself on the left-hand side of the equation? So we're going to try and isolate y by subtraction, addition, and multiplication, division. In our solution, first we have to move the x. So we start out with 2y plus 4x. To move this plus 4x to the other side, we have to subtract 4x. That way, plus 4x and minus 4x will be equal and opposite and go away, and just leave me with 2y on the left side. What I do to the left, I have to do to the right, so this -6 also has to be subtracted by 4x. But these two are not like terms. I can't combine a 6 and a 4x. For that reason, I have to leave them separate. It would be valid to write -6 minus 4x. That would be mathematically correct, but we want to get used to putting it x's first, then numbers, because that's going to match with our slope-intercept form. So instead of writing as -6 minus 4x, I'm going to write it as -4x minus 6. And now I have 2y equals -4x minus 6, which is really close to what we want. We want the form of a line where we just have one line on the left-hand side. What that means is we're going to have to undo this 2 that's being multiplied by dividing by 2. Divide this side by 2, and that 2y is going to become just y. What we do to the left, we have to do to each term on the right, so we have to divide -4x by 2 and -6 by 2. -4x divided by 2 gives me -2x, and -6 divided by 2 gives me -3. Y equals -2x minus 3 is the correct equation solved for y. Graphing linear equations by plotting points. This tells you to use 3 pairs of points to satisfy the equation in order to plot. That's what it's going to ask you during the homework as well. 2 technically makes a line, so really if you find any 2 points and you draw the line through them, that's the only line that can exist. But by doing 3 points, If a line doesn't go through all three, you know that something went wrong. You can go back and check which one might be off. 3 points really gives you a way to check. So if you can draw a straight line between all three, that's a good thing. Let's say we wanted to graph y equals negative 3x. First, we want to find three solutions of the equations and plot them on a coordinate system. Then we can draw a straight line through the points. Here they say, let's try x values of negative 2, 0, and 2. Personally, I like to try negative 1, 0, and 1 because to me that's the easiest possible things to put in, but it makes sense to do negative 2, 0, and 2 as well. If I put in negative 2 to y equals negative 3x, the negative 2 goes in where I see an x, and I want to put it in parentheses. So really what's going to happen is it's going to be negative 3 times parentheses negative 2, which will give me positive 6. Here when I put in 0, negative 3 times 0 is going to give me 0. And finally, when I put in positive 2, negative 3 times positive 2 will give me negative 6. So I now have an x point or an input I put in, and a y or an output I got back. So the ordered pair that I've been given, negative 2, 6, 0, 0, and 2, negative 6. I can write each of these as ordered pairs. I can plot them on my coordinate plane. So here we have it, the three ordered pairs that were created. If I start at negative 2, 6, then from the origin I go left 1, 2, I go up 1, 2, 3, 4, 5, 6. Here's the point negative 2, 6. If I want to graph 0, 0, that's this point right here. And if I want to graph 2, negative 6, I go over 1, 2, down 1, 2, 3, 4, 5, 6. So here are the 3 points that I plotted. After those points are drawn in, I can use a line to connect them all. When you're doing these in the system for Cengage, it asks you to first plot the points, put them in, and then use the line tool to connect them. Make sure you're putting arrows on either side of the lines to say they're going on forever. Graph linear equations by the intercept method. So the intercept method is going to ask us, where do these things equal 0? First, we're going to put in 0 for y and solve for x. Then we're going to put in 0 for x and solve for y. Hopefully that'll give us 2 different points that we can then connect and draw a line. So in the figure to the right, the graph of 3x plus 4y equals 12. Notice that it has an intercept at the point 0, 3, and it has an intercept at the point 4, 0. By connecting just those 2 points, we can graph the line. So looking at the graph, we can see where it crosses this y-axis, which is when x equals 0, and where it crosses this x-axis, which is when y equals 0. The y-intercept of the line is the point 0b, where the line intersects the x-axis. To find b, substitute 0 into x for the equation of the line and solve for y. So when we want to find a y-intercept, plug in 0 for x. When we want to find an x-intercept, plug in 0 for y. Basically, whichever intercept you want to find, plug in 0 for the other variable. Plotting the x and y intercepts of the graph and drawing a straight line through them is called the intercept method of graphing a line. Method's useful when graphing equations written in general form. So let's say this was our original form, 3x minus 2y equals 8. If I wanted to graph this by the intercept method, I would start by plugging in a 0 for y. So we're going to let y equal 0 to find the x-intercept of the graph. We'll then let x equals 0 to find the y-intercept. So if I plug in 0 for y here, negative 2 times 0 gives me 0. So this term goes away, and I'm just left with 3x equals 8. If I get x by itself, I divide both sides by 3, and I get 8/3, which is a little bit of a sloppy number. We'll show you that you can call it the mixed number 2 and 2/3. I really try and give you stuff that is going to be whole numbers for the most part. But basically, as long as I divide both sides by 3, I'll get to the correct answer. So this is showing when we put in 0 for y, we get to 3x equals 8. which really means that x equals 8/3. Again, it can be written as this mixed number. I don't really care that much between mixed numbers and fractions. The ordered pairs then entered in the table below, so 8/3, 0. The next thing I can do is I plug in 0 for the x coordinate. If I put in 0 for x, 3 times 0 equals 0, so I'm just left with negative 2y equals 8. If I divide by negative 2, that'll leave me with y. If I put in my calculator, 8 divided by negative 2, that's how I get this answer, negative 4. So really, these 2 points, the x and y intercept, are enough to graph. They show plugging in another number just to get another checkpoint and say, when I put in a new number 4, does it give me a point on the line that I graphed? It does, so it does work out. So this is showing we put 0 in for x and get that negative 4, which means 0, negative 4 is a point. So here's 0, negative 4. Here's 2 2/3 or 8/3, 0. If they do this checkpoint and say, is it on the same line? It is. So at the end, the last thing they do is they do a check. They plug in 4 for x, get back 2 for y, and show that yes, this is on the line. Identify and graph horizontal and vertical lines. So a horizontal line runs left to right like this. A horizontal line has a y equals equation. A vertical line runs up and down like this. A vertical line has an x equals equation. When I say y equals or x equals equation, I mean that the other variable does not exist. So the other variable is set to 0 in the equation. X equals negative 5 means you can put whatever you want in for y, and x will always equal negative 5. Y equals 2 means you can put whatever you want in for x, and y will always equal 2. Equations such as y equals 4 and x equals negative 3 are linear equations because they can be written in this general form, but we want to talk about how these linear equations look when they only have one or the other, either x or y. So if I went to graph y equals 4 and I wanted to find 3 ordered paired solutions, the equation is 0x plus y equals 4, so I can plug whatever I want in for x, and I'm always going to get 4 back for y. So the numbers that I choose for x do not matter at all on what the outcome is for y. If I put in x equals 2, 2 times 0 equals 0, so y still equals 4. That gives me the point 2, 4. If I tried negative 1, wouldn't matter, y would still equal 4, so the point is negative 1, 4. If I try negative 3, y still equals 4, so I get negative 3, 4. Basically, when you have a y equals a horizontal line, choose whatever you want for x, but make sure that y always stays as that value, 4. So if I look at them as points and graph them, it will create this horizontal line at y equals 4. So when I have horizontal and vertical lines, if the equation is y equals something, it's a horizontal line running at that value b. If it's x equals something, it's a vertical line at that value, x equals a.